My name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GRE. We have been solving GRE math problems out of this book here, the official guide to the GRE, the revised general test. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 246. Page 246. Today is our lesson number 160. And the problem that we're going to solve is 21D. 21D. And we are given a function which is f of x equals square root of x plus 2. We are going to start our story with something simpler. Instead of f of x equals x plus instead of f of x being equal to the square root of x plus 2, let's first contemplate f of x equals to square root of x. Let's understand what that means, and before we make the transition to something that they're giving us. So in order for us to understand this part, can you tell me what this question says? The square root of 9. I'm not asking you what that equals to. I'm asking you, what does the question ask? When you ask somebody, what is the square root of 9? What is it that you're asking the person in plain English language? What is it that you're asking? What we are asking here is, this is same as, what we are asking here is, what is that number which when multiplied by itself gives us 9. That is the question. Think about it. What is that number which when multiplied by itself gives us 9? And the answer of course is 3. 3, because 3 multiplied by itself gives us 9. That's what it means. The square root of 3 times 3 is 3, because whatever we see in the square root sign, what it is asking is that, what is that number which when multiplied by itself gives us 9? But is that the complete answer? The answer to that question is no. It is only half the story. What it should have said is, this is misleading. What it should have said is that, what are those numbers which when multiplied by themselves, I didn't realize I had to make so many changes to make it plural, give us 9. What are those numbers which when multiplied by themselves give us 9? Because there are two answer choices. And the second one is this. Square root of 9 also equals square root of negative 3 times negative 3. Negative 3 times negative 3. Therefore square root of 9 also equals negative 3. Square root of 9 doesn't just equal 3. Square root of 9 equals positive 3 and negative 3. Because both positive 3 and negative 3, if you were to square them, we'll get our positive 9 back, which is this guy right here. Of course we understand this part. This was very simple. The prickly bit is coming up. This wasn't the point of our discussion here. The prickly bit is coming up. So let's go to the prickly bit, okay? Let's ask ourselves a new question. Let's ask ourselves a new question. What is that number which when multiplied by itself gives us 9? Gives us negative 9. What is that number which, when multiplied by itself, is going to give us a negative 9? Think about it. Can you think of any number at all which, when multiplied by itself, is going to give us a negative 9? The answer is no such number exists. No such number exists. Why? Why? Because a number, by definition, is going to be either positive or negative, leaving aside the 0 for the time being. Because 0 doesn't play any role here, because 0 times 0 is 0. It's not going to, there's no way you're going to get a negative 9 there. So a number is going to be a positive or a negative number. If the number happens to be positive, then a positive number times itself, is going to be positive. But if the number happens to be negative, a negative number, like a little while ago we saw negative 3 times itself, is also going to give us positive. It is impossible, it is an impossibility for a number to be multiplied by itself and produce a product of negative 9, or negative any number for that matter. You cannot multiply any number, I'm going to say it one more time, you cannot multiply any number by itself and have a negative product. One cannot multiply any number by itself and have a product of a negative number. It is impossible. It is impossible. Therefore, the limitation for the x is that, therefore the limitation for the x is that this x underneath the root sign cannot be negative. It cannot be negative. Because if it's negative, if the value of the x in the root under the square root sign happens to be negative, we got a bit of a problem, because it is impossible to figure out the square root of a negative number. One more time. What's the square root of negative 9? Which is same as asking, what is that number which, when multiplied by itself, gives us negative 9? The answer is no such number exists. No such number exists. One cannot multiply any number by itself and have a product of a negative number. And have a negative product is what I meant to say. Have a negative product. It is impossible, which means we're going to have to impose a condition on this guy. We're going to have to tell this guy, you better not be negative. You can be 0. You can have a square root of 0. Of course, you can most definitely have a square root of 0. The square root of 0, when you ask somebody what's the square root of 0, that is same as asking what is that number? What is that number which, when multiplied by itself, gives us 0? Which of course is 0. 0 times 0 is 0. So 0 is fine, but you cannot have negative numbers. That is the limitation on x. We're going to make a note of it. There is a limitation on x. This x under the root sign, this x under the square root sign cannot be negative. Now, how do we say this thing in the language of mathematics? This is the English language. How would a mathematician say the same thing? This is how the mathematician would say. Mathematician would say the domain of this function is set of all non-negative numbers. Listen carefully. Non-negative. Non-negative numbers is how they speak. Why don't they simply say positive number? Why do they have to say in such a way non-negative numbers? Why don't they simply say positive numbers? Because if you were to say just positive numbers, positive numbers, then you're going to have to also specify that it can also be 0, plus, not plus, I don't want to confuse anybody, positive number as well as 0. You're going to have to specify it, because it can also be 0. It's okay for x to be 0, it just can't be negative. Since it can be 0 and all the positive number, we can't just say just positive number, because then we have to say as well as 0. Instead of saying positive number as well as 0, they say non-negative numbers, because 0 is non-negative, 0 is not negative, 0 is not negative. So when you say non-negative, you pick up the 0 along with all the positive numbers. Do you understand? That's all it is. That's all it is. So here, the domain of this function is set of all non-negative, and I left out an adjective there, non-negative real numbers. Now, let's talk about that part here for the time being. I'm not going to make a big fuss about it. You're going to see this word all the time, real numbers, and you're going to wonder what the hell does it mean, or how can number be imaginary? Trust me, for mathematicians, they live in two worlds. They live in the world of real numbers, and they also have what they call imaginary numbers. But that is abstract mathematics, that's the high-level mathematics you will never ever encounter on the GRE. So don't worry about it, okay? Just ignore it. When the book talks about a set of real numbers, just read that as set of numbers, that's all. Set of numbers, any old number. When they talk about set of real non-negative numbers, it simply means it cannot be negative, but it can be 0, it can be positive numbers and 0. That's all it is. So that is the domain of this function. The domain of this function is all non-negative numbers. Now how do we write all of this? Of course we're not going to write like that. Mathematicians are not going to write all of this thing. Each time obviously they have to have some concise way of putting it in their own jargon, in their own language, and this is how they do it. Okay, watch what happens. This is how I'm going to erase this arrow so that we can actually concentrate on how it's written. They write it like this, and then they put a comma, and they simply say x is greater than or equal to 0. That's all there is. That is the limitation on x. And this part that we talked about, this part that we just mentioned, x is greater than or equal to 0, this part right here is what they call the domain. Right here, the domain. When they talk about domain of a function, what they're asking is, what are the allowable values for the independent variable? X is the independent variable. Why is x the independent variable? Because the value of the function equals y. So y equals root of x. Since y equals root of x, the values of y, what value y can take depends on the value of x. When x is 1, y is 1. When x is 2, y is square root of 2. When x is 4, y is 2. When x is 9, y is 3. The value of the y depends on the value of the x. Therefore, x is called the independent variable, y is called the dependent variable. Independent variable and y is called the dependent variable. How did I get into this thing? Remind me? How did I get into this thing? Anyway, that's how they write it. F of x equals root of x, and then they put a comma, and then they say x is greater than or equal to 0. That is the domain of the function. Oh, that is the limitation. That is the limitation on the independent variable. What does it mean? The domain of a function. It comes back to me now. What does it mean? Domain of a function. Domain of a function simply means what are the limitations on the independent variable. Domain of the function means what are the limitations on the independent variable. Domain of a function means what are the limitations on the independent variable. That's all. That's all it is. Now we're going to pick up what they're asking here. Now that we understand this part, let's pick up what we're asking. That's it. We're done with all of this thing. Now what they're giving us is this part right here. Since I used up the letter F, since I used the letter F to denote this function, I cannot call the new function the same name. I cannot give it the same name. That will be confusing. I'm going to call it g of x. This f and g and h, they are simply names of the function, names of the relationship. This is a new function. So now when we talk about the domain of this function, we're asking the same question. We're asking the same questions. What are the limitations on the independent variable? The limitation here is that this quantity, the limitation here is that this quantity under the square root sign cannot be negative. This quantity under the square root sign cannot be negative because, as we just discussed, we cannot find square root of a negative quantity. It doesn't exist. Therefore, the limitation here is that x plus 2, this quantity right here, x plus 2, has to be either greater than or equal to 0. X plus 2 has to be greater than or equal to 0. If you subtract 2 from both sides, of the inequality, we get our domain. X over here has to be greater than or equal to negative 2. Voila, this is your domain. X has to be greater than or equal to negative 2. It can be negative 2, which is fine. Let's put this thing a little bit to the side here so that it doesn't touch each other, and so that here, the limitation here is that this quantity right here, the limitation here is that this quantity under the square root sign cannot be negative. And how do we say that? This is how we say it. We say that this quantity x plus 2 has to be greater than or equal to 0. It's okay for it to be equal to 0. We can find square root of 0, obviously. Subtract 2 from both sides one more time so that you can see it. And this is how we say it. X has to be greater than or equal to negative 2. When x is negative 2, negative 2 plus the 2 is 0. We can find the square root of 0. When x is negative 1, negative 1 plus the 2 is positive 1. And of course we can find the square root of positive 1. When x is negative half, of course we can find the square root of 1.5. As long as x is more than negative 2, so this is how we show it. If they ask you to show this, this is called the domain. This is called the domain. This is the domain right here. This is the domain. Domain of a function means what are the limitations on the independent variable? The limitation on the independent variable is that it's got to be at least 2. It's got to be at least negative 2. That's how we say it in English language. It has to be at least negative 2. It can be equal to negative 2 or something more than that. One last thing, just show it on the graph. Sometimes they ask you to show it on a number line. This is how we show it on the number line. Here's your number line. This is your 0. This is our positive 1. This is our positive 2, and it goes on forever. This is our negative 1, and this is our negative 2. Since it's allowed to be equal to negative 2, we have to include the negative 2 point. And this is how we show it with a closed dot in it. And then you darken it. Voila. You darken this part. And this is the domain of g of x equals square root of x plus 2. And that is all. That is all it is. That's all they are asking here. It says, I'm reading the question number 21 now. It says, for each of the following function, give the domain. We just did that. Describe the graph. Well, we're going to do that in a second. We're going to do that in a second. We're going to plot the graph, and then we're going to talk about its shape. We're going to talk about the x-intercept and the y-intercept. Let's do that next. I need the room, so I'm going to erase everything, and now we're going to talk about the graph. As far as the domain is concerned, we are done. What are the allowable values for x here? Well, x can be anything it wants to be, as long as it does not go below -2. That's all it is. Let's plot it, shall we? I need the room. Now, let's plot it. So here's your x and here's your y, which is square root of -x plus 2. When x is -2, when x is -2, we get square root of -2 plus a 2, which is same as square root of 0, which is 0. When x is -1, -1 plus a 2, which is square root of 1, which is 1. When x is 0, we get 0 plus 2, which is square root of 2, which is approximately 1.4. And when x is 1, 1 plus 2 is 3, we get square root of 3, which is approximately 1.7. And when x is 2, we get 2 plus 2, which is 4. Which equals 2. That's it. I'm going to rewrite all of this thing instead of writing the baby way. Y equals, when x is -2, -2 plus 2 is 0, so the y is 0. When x is -1, -1 plus positive 2 is 1, the square root of 1 is 1. When x is 0, y is square root of -2, and square root of -2 is approximately 1.4. When x is 1, 1 plus 2 is 3, square root of 3 is approximately 1.7. And when x is 2, 2 plus 2 is 4, and the square root of 4 is 2. You must know your square root of 3, the square root of 2, the square root of 3, and square root of 5. I spent a great deal of time just in the last video, which is a very long video, explaining just that concept. Don't reach for calculators for every single thing, for crying out loud. Do you understand? There are some things that you have to know. You must know by heart. These are some very elementary things that you should know. You should know that square root of 5 is approximately 2.2. It comes in very handy. You must know that the square root of 3 is approximately 1.7. Because 17 times 17 is somewhere around 300. Because 14 times 14 is somewhere around 200. 14 times 14 is 196. Therefore 1.4 times 1.4 is going to be 1.96. Similarly, square root of 5 is around 2.2. Because 2.2 times 2.2 is 4.84, which is about 5. You should know these things. Let's plot it. When x is -2, y is 0. That's the first point. When x is -1, y is 1. Let's put it a little bit higher so that we can see here. When x is -1, y is 1. When x is -1, y is 1. When x is 0, y is 1.4. When x is 0, y is 1.4. This is 1.5, so it's somewhere here. When x is 1, y is 1.7. This is 1.5. This is 1.75, so it's somewhere around here. When x is 2, y is 2. Let's see what this graph looks like. It looks something like this. Voila. It's a parabola. It's only half the parabola. Why is it only half the parabola? Because these values are not allowed. These do not exist. The values of y's are going to be only positive values. Why is it that the values of y's are only positive? Because it is impossible for us to multiply a number by itself and get a negative product. So that's what it is. This bottom part does not exist, only the top part exists. Only the top part exists. It is half a parabola. Let's make a note of it. It is a half a parabola. It is half a parabola opening to the right with vertex at, where's the vertex? Right here is the vertex. -2 and 0. Now let's talk about this x-intercept and y-intercept. Let's talk about it, x-intercept and y-intercept. What does x-intercept mean? X-intercept means the value of the function when y is 0. Well, that's right here. When y is 0, right here. When y is 0, x is -2. Voila. When y is 0, x is -2. So this happens to be its vertex as well as its x-intercept. Right here. This is his x-intercept. The y-intercept is where the graph cuts the y-axis. The graph cuts the y-axis right here. Right here. When x is 0, y happens to be, when x is 0, y happens to be 1.4. Voila. This is his y-intercept. This is the y-intercept. Right here. That's it. Now we have discussed this x-intercept and y-intercept. We talked about its vertex, we talked about its shape, and we understand the domain of this function. The domain of these functions are whole positive number as well as 0. X can be 0 or any positive number. Instead of saying x can be 0 or any positive number, mathematicians say that x has got to be a non-negative number. A 0 is a non-negative number because 0 is not negative. 0 is not positive. So when you say non-negative, you include 0 in it. That's all it is. That's all. We are done. We are done with this graph. I will see you tomorrow when we'll do the very last one, again in a similar fashion like we have been doing in depth, so that we understand it. Okay? I'll see you tomorrow. Bye now.